Hello, welcome back. I'm sure you would have enjoyed that long break and you're back with full of energy. We left it with this coding with three errors that shows in the initialized task. In here, this line, it doesn't agree with the syntax errors. So to fix that, I have to go up here and check the tick start. So there is two brackets, three brackets finished with true. So this is where the fault is. I didn't close the end. And so now I'll save and rerun, compile the project, build the project. Okay, has gone through now. Oh no, not really. 6 errors. Save PSP value. He got 6 errors. So now it moves from the stack. It's accepting the task, but now there is a problem with the user task of idle stack with the task 1 handler. So let's go to task 1 handler of void printf while of 1 task 1 of handler. Undeclared first use in this function. Task 1 underscore handler. Okay, dummy max. Let me finish this initialization dummy part and I'll recompile again to see what the problem is. So we'll start with here. So inside the for loop, you have to declare the PSP value, and that would start with uint 32 underscore t. And link with user tasks with the iteration of I, and connect with the PSP value, PSP underscore value. And then you decrement first the PSP value, start to decrement, and then send the dummy value, set the dummy value. So asterisk p small p capital PSP, you link that with the dummy value. Dummy, I think it's dummy underscore x psr. I'll double check up here. Will be dummy caps underscore x psr. Okay, that's good, that's correct. Dummy x psr. Again decrement from there, so use this copy and paste here. Then we're linking that with the task handler. So the user task is now linking with the task handler. So I will copy this, come here paste it. So the PPSP value, the user tasks of 5 got the value. Now to the setting to the task handler. Task underscore handler. Okay, you're linking to the task handler, and then you're decrementing again from the task handler. So copy that. And then the next one, you're executing the return function. So from the register, instead of dummy value, you're putting the return to PSP, the process stack pointer. So copy this, come here and paste it. So the PSP value will be from the register 0 cross 4Fs 6 4Fs. We'll start again. 0 cross 4F and FFFT is the value we need to load. Yeah, this is for the execution return behavior. Execution return behavior. Okay, I'm just putting a for loop, simple for loop, to check the iterations to check with the stack pointer j and j plus plus. For loop, open the bracket, close the bracket. Inside the for loop, you again decrement this PSP register, and then once it decrements, reset this value to 0. Reset this value to 0. For loop, finish in that for loop. So now we have written the dummy program. I think I'll check again with the user tasks. Link to the user tasks of the value. So I link this to user of tasks to the task handler 4 with PSP value, checking with typecast T and linking that with the pointer PSP value. Okay, let me save this and rerun to see if I linked that correctly. So right click, build the project. Sorry, supposed to be the other lowercase p, and this is capital PSP. Again here, small p and capital PSP. Save this and rerun again to see what error we get. Still 8 errors and warnings. Okay, PSP undeclared. Oh, sorry, it's supposed to be a small p with capital PSP as the dummy register. Small PSP. So now it should clear this dummy errors. Okay, we cleared one, but there is few more to do. Okay, I'm just going to the presentation, just one sec, to see if we have got this correct. So copying this register value, which is 1 2 3 4f and 3f and d, then you're creating the macros, which we did, and then we enable this, we copied this, and we did the system initialization, task handlers, and the registers. You in 32 PSP value, the current state, and then you declare the task handler, and then the user tasks, return with the PSP value, save PSP value with the current PSP value. Yes, that's correct. So the update task is checking and then incrementing the task with the modulus, then state, you are declaring a state, but I used a for statement, and ms or msb, that's there. Okay, this is the dummy state. So task ready state is okay, idle stack start is okay, task handler is idle task, then task one underscore handler, all this okay. Then you need to declare that u int 32 declaration, and then go for the first with PSP value, then you're decrementing that value and then setting the dummy register, and then the program counter decrement, and then the link register decrement, then you saving that, then you are saying user task of high PSP value is PSP. Okay, I think I know what error I made. Instead of 4, this is I, the user task of I, that's so we declare that I, user task of I, and we are creating another function J. So I'll save this and rerun once more to see if I eliminated few errors. Just bear with me, please. Why the task handler is throwing error? Task 1 of y, task 1 underscore handler, idle task, task handler, task 1 handler. Task 3, task 4, you declare that handler in all here separate. Okay, that's good. User tasks of I, maximum tasks. So did I declare max tasks? Max tasks, yeah, current task, that's okay, that's 5. Sorry, I'm just going through my routine to check where I went wrong. For int I equals 0, then for declaring int j equals 0, if I save this and rerun again the second for loop, okay, need to go back to the slide. What I miss, PSP value user tasks, your decrement is 0, then that's D, then you're decrementing dummy decrementing, okay, task handler, So the task handler should be that. This far and that far and then closed. Space. So the PSP value of PSP dummy, the PSP dummy XPSR, then the PSP dummy is that value. Is a tasks of I, task handler, user tasks of I. The PSP from the program counter. Sorry, the dummy tag, that's not a pointer, so that's the problem. PC, this is LR. PC and LR. So this is program counter decrement, and this is link register decrement, and this is just a task handler type. Okay, event. So it should be happy now. Let's see. Check. Build project. Still not happy. PSP value, user of tasks that is given, PSP 0. Unit. Sorry, my bad. It's uint. My typo. See? uint 32 underscore t now is will agree to this assignment. 32t uint 32 underscore t. So this should be happy with the PSP now, the dummy value. So I'll go and check. Right click, build project. Okay, so that we eliminated that issue by declaring that wrongly. PSP assigned to u32, also it's assigned for a pointer, so it's asking to leave this to be a pointer. Okay, let me try this. If I write that to be a pointer, right click and build again. 5 errors and 1 warnings. Okay, the task handlers are not declared. It's saying task handler underscore task 4 underscore handler, which is here. Task 1, task 2, task 3, task 4, task 1 underscore handler. So I think I have to declare as a global. Control C. I'm going to declare this up in the top. So here. Let me mute comment these lines to see. Okay, save, right click, build the project. Fingers crossed this time because we declared globally. Okay, so that's my bad. I copied the other day and we created the task handler, and has to be declared, those functions has to be declared globally. So by doing that we eliminated the error. Okay, thank you for your patience to be with me to learn this far. So it's not far to go. So the next step is you need to get this value. So the next step, you need to switch stack pointer to PSP. Initialize the dummy value. So here, next step, you need to switch SP stack pointer to PSP. So I'll go to the presentation, I'll copy the steps so we can do that one by one. I'll copy this, go to the code and paste it so we won't miss any step. First step is to preserve and then get the PSP value and then initialize the PSP, then retrieve the LR, then change SP to using control register and do the return. So let's start with the first one is the push function to preserve. Start from here. You need to write the assembly program. ASM volatile ASM volatile, and then use the push to the link register, push off the link register, the LR register. So that's the first step. Then get the PSP value of the current task. Get the PSP value of the current task. So just copy this ASM, come here and paste it and change it. Next, get the PSP value. So you need to click branch out, BL, and then copy this get PSP value. Get PSP value. Come down. Get PSP value. Okay, that's the second step. Then initialize the PSP. After that, you're going to store the value and initialize it. To do that, you copy this again. Control-C for initializing. Come here. My mouse is playing up, sorry. Now you need to initialize PSP, so by doing MSR special function register PSP, and then you got to set that to R not. This is to store the value. And the next step, you got to retrieve the value by using pop. So I'll copy that again, go here and paste it. So this time you got to use pop to retrieve the data. Retrieve the stack register, pop, and then link that to the LR, link register. Link register. Okay, now change the stack pointer to PSP using control register. To do that, you need to set the bit 2 to stack pointer. So I'll copy this again, Control C, Control V. We're going to set this first move. By using move command, you're going to enable that bit move R0, comma, you're going to declare and enable that bit, sorry, it's a move command, MOV. MOV, move command. Okay, so copy that, and then now you need to link that to the ROASM with the control command MSR using control. You got to link that to R0. Yeah, and then you're calling that and function to return call, so you just simply write bx, come out of the function bx and lr. So we got to put this in the attribute. So we got created all of these steps, but before that we need to set the attribute. For that, I'm going to copy this attribute again, this whole attribute, copy. You got to use that attribute here. So this time you're going to use switch SP to PSP. SP of void. Okay, we return the attribute and close it, and we have to declare this attribute up here, the prototype up here. So go all the way to the top, and you can save it here. Save that file. So now we did PSP underscore or not PSP value. There should be a comma in there. This should come, but I don't know why there is the red line. So okay, let's compile and see if there is any error still. Right click on the project, build the project to see if it accepted this assembly code. 3 errors. The first error is attribute being an attribute. We got to pass the value before switch. One sec, just give me a sec. ASM volatile, MSR, PSP or not. So we copied all of that. So I'll go back to the presentation to see if I haven't missed any steps. got this. First we pushing the LR and then getting the PSP value, then PSP R0, then pop, and moving R0, then control R0, then we are exiting from the function. So it should white switch SP to PSP. Okay, I think it's the attribute name may be wrong. I created switch there. It didn't take the value of the attribute by the looks. Ah, it took that as a switch, so sorry. Switch. Come here. Because switch is a keyword, we can't use switch, so I need to copy that to a function name. So this will correct the error now. Switch PSP value R0 control white, switch off white, so that is okay. So now let's save and compile to check for this assembly. Okay, so far it looks good and I think it's happy now. Yeah, so the next step now is to write the code for avoiding the prologue and epilogue sequence. So for that you need to write a sysdig handler. So again you copy another attribute because it needs another assembly language, so copying that for the sysdig handler. Control V. Okay, so this will be sysdig handler. Sysdig handler of void. Creating, copying this attribute, copy, go up and declare in global declaration, come here and paste it. Okay, so what we're going to write in here to avoid that prologue and epilogue values, so go into sysdig handler and then you need to copy all the steps from the presentation, which is the next step about the context switching. So we need to include this into the ASM program. So copying this, come in here, saving all the steps. So get the current running task of PSP value, then all these steps you need to write in assembly language. Okay, so the first step is to link with MSR PSP. So you got to copy this to get the current PSP value. So that's the MSP. We copying that to R0 or not, comma PSP value. Okay, so that's the first step. Then you need to store that and tell the register. So to do that, paste it, and then the next command is we are telling to manually store from registers R4 to R11. So to do that you need to use stmbd store stmdb and then link with R0 value of the register. Then you're going to declare what registers you need to use, so which is the range R4 to R11, R4 to R11. Okay, the next is you need to push the value, so you got to use this function, push the value to the link register with the push operations again, and then now you saving the value to the current value, the PSP. So I'll save this here and then get the PSP value to save. So BL branching index, and then copy the save PSP value, save PSP value, Control C, come down, okay. The next step is to decide next task to run. So you need to tell the compiler where you need to run. So before doing that, I will do a short check to see if I made any errors so far. Because being a lengthy program, it is a good advice to check whenever you write few functions and few commands, then you check there so you won't miss any problems. So see, there is 2 errors. So I made some syntax error, which is terminated with exit code, subdirectory, assembler messages, asm volatile sysdig. Okay, it says I run with some error. I'll check where it is. lr push lr, then bl save msr we are reading now we are reading value, we are writing that value, mrs register, sorry, mrs save, just build to see if okay, it's a different register, special function register we are writing to it. So get current running task and move that value to the register or not. Okay, so far so good. So the next one, you need to say update task, update for the next task. So come here and paste it, and you need to branch out to update next task. So remember, we wrote a program for update next task, so copy this program, function name, you need to link this to the next state saying where it has to go. Okay, then get its previous state value to extract out. To do that, you need to get the PSP value again. So copy this, get the previous value, so change save to get underscore PSP value. So if you go up here, you need to copy this function name, get underscore PSP underscore value, get underscore PSP underscore value. Then again you retrieving the PSP value for the registers R4 to R11 through load register. So LDMIA register, special function register, so copy that, special registers. This time you using LDMIA, you're loading the registers, the range R4 to R11, which is good. And the next step is you're updating the PSP where you're working on. So for that you need to set the read this time, Control C, update the PSP, Control V, so you're setting it as the other way. So MSR and PSP comma R not. This time you're updating the PSP. Then retrieving by the link registers. So you need to use pop. You used push here, so you need to retrieve that register. So you got to use pop register for that. Instead of push, use simple pop. And then the last one, you got to update and exit. So BXLR. So just copy this update and exit. Copy. Paste. So we did write the program. Now go right click and build the project to see if there is any error at this stage. Okay, so far it looks to be happy, it's going through. Now we have to update the main program. So go into main program, task handler, void update, next type def void. Okay, so now we need to enable and call all those functions that we just written. So the first step, you need to call the initialize task init scheduler task. You need to call that function after the processor fault. So you need to call that with the sched stack, with the schedule, because this is where the scheduling starts. Schedule start stack. Call that function into the scheduler tasks. Yeah, and the next one, you need to call all the task that you just created, init tasks, which is this one, init task stack. Calling this function, which is good. And then next, you calling the init sysdig timer. We just generated the sysdig timer, so you need to call this. Next step, call that. It's just a function call. Tick. It is already there, so I didn't see it, sorry. We already declared. So the next is you need to call the function, the stack pointer to PSP, the switch. So you need to copy that switch to PSP, call this function into the main. And then finally you got to say which task handler it should go to. So we need to direct this to go to task 1 handler. Control C. Or let's start with task 2. I'll ask it to go to task 2 to see if we can get any error. Okay, we initialized all that. So now I'll go and build the project. Say right click, build the project. So far so good, no errors, which is good. Now I'll set that to debug. So right click, debug with options STM32, STM32, and then choose the scheduling algorithm EF and say OK. And make sure that ELF is set and the debugger, the ST link is set and the serial wire viewer is set. Click apply and then say OK. This is to view the output in the console ITM. So because we are using ITM with the processor error, so let's go. Once it finishes, then we'll start the trace switch. We are in switch. Yeah, okay, it's ready to run. So go to SWM, start the trace, and set this port 0 to be enabled. Okay, and then go and run. So now it's coming as executing main, so and then it comes as a exception bus fault. So there is a fault, a bus fault, so it is going initializing. So that's why we included this, all the bus handlers. So now in the executing stage it goes to bus fault and it doesn't go through after that. So I have to check executing main task 2. Immediately it's going to, instead of going to task 1, it's going to task 2. So I will terminate and relaunch, go step by step to understand where that error is. So click on OK, and let's check where this error is coming from. Sorry, this looks to be a bit lengthy session, but we are debugging, so which is really good. Debug, choosing that algorithm, okay, and then we're setting to debug. So now I'll go step into section to find out where the problem is. Switch, okay, come to SWV, I'll go into step into instruction. So executing main, which is good. Then it comes to the enable processor fault, then it goes to the usage fault, comes out of the usage fault, it enables a bus fault, checks with the memmanage fault, and then it goes to the scheduling task, checks with the schedule task, and checks to the function call, and then it goes to the tasks, it checks with all the tasks, executing main. I should set a breakpoint at the task 1 and then step into that, will give a better idea about why that bus fault happened. Okay, we are nearly there. Checking iterations, resetting, it will decrement. So I'll go one step over. Okay, step into, we are checking the registers, that's checking. Okay, initializing, and then I'll hit the run button, hit run again. So again it comes as a bus fault, wired bus fault handler. So I'll start with changing this, assigning this task to that's okay. In the program, main program, I'll change to task 1 handler. Task 1 handler. So relaunch. task 1 handler, hard fault. I'll set a breakpoint here. Breakpoint there. And then say if I can change the main program to see if I can get to that point. Switch. Go to the main program. I'll just check this idle task, executing main. So I'll just play with this, executing exceptions. Sorry, this should be main. Executing main inside the static handler. Switch while printf inside switch. So inside here, instead of test tick, just write task 1, task 1, task 2, task 3, stick handler. I will type executing exceptions. Let's check executing exceptions. Terminate and relaunch. Not far to go. One warning, okay. Yeah, switch. Okay, now go to the data console and run this program, executing main. So it comes to task 1 handler. Because I set the breakpoint, it stops there and comes to bus fault. Still comes as the exception bus fault. Okay. Executing exceptions for every printf. Okay. So the PSP in the breakpoint task handler. With the task handler, this should be a pointer, I think. Terminate and relaunch. Okay. Debug as, choose his scheduling algorithm. Okay. Wait for it to load to 100%. It's checking. And then we'll run and see what stage we are up to in the nearly there. Switch. Error in in the debug mode. It's about to launch. Okay, we are in the debug mode, executing main, and if we come to the data console and go and hit the run button, then run again, executing task 1, executing exceptions. It's only executing the exceptions and it's not going to the task, so exceptions. Okay, so it's going into the task handler. You need to copy this into the while statements, into that, printf into the while. So this should say as 4, and this should say as 3, and that's 2, that's 1. Okay, I'll come here, remove all the breakpoints. Right click, remove all the breakpoints, remove, and then terminate and relaunch. It's 51%, nearly there. So we are asking it to schedule, and then now we are compiling it and we putting those messages inside the task handler. Now we'll see the output. Okay, let's open the console window and then hit run now. So see, now it's starting to schedule, executing task 1, and once it finishes that, then it will execute task 2. So it is starting to schedule. Scheduling. So I'll stop this. Task 1. Come to the main program. Current task, that's okay. Control reaches end of non-void function. Okay, I got to compile to see what those errors or the warnings were. Current task, that's okay. Current task is okay. Task 1 handler, it's not moving to task. 0 warnings, okay. Static handlers. I'm wondering, okay, that's there, that's okay. save that and rerun. Let's see if it schedules. Build project. It's building the project. It will go to debug in a second. Just one sec. Just one second, it's loading. Right click, debug as. Debug as. Okay. Zero errors, zero warnings, which is we wanted 79%, and we're going in switch. And we are in the program, so I'll open the data console. I'll go and run this program now, executing main, then run again. Executing task 1. So it is working now. It is going into the task mode, and it is going into the handler, and it is working with the task handler.php. It is going there, and stick handler. And terminate this stick handler. Stick. Stick timer, enable get PSP current task, task 1 handler, stick timer. So I'll quit and relaunch, because we have written two different sysdig, one with the assembly and one sysdig handler, and one with the normal function. So it's conflicting each other. So now let's see. Okay, then click on switch, come here and run the program. Open the ITM data console, run, executing main, executing task 1, task 1. Just give me a sec, I will come back to resolve this. Just one sec, I'm just going through some error check, and I'll come back and resolve this. Don't go anywhere, I'll fix this shortly. So I'll see you back shortly.